Today we are going to explain to you how to do a soil compaction experiment. Soil compaction measurements are important in determining the optimum water content for compaction in a soil. In agriculture, one may want to avoid driving on fields when water content is favorable for soil compaction. Soil compaction is important for a variety of reasons. Soil compaction can hinder root penetration, water infiltration, seed emergence, nutrient availability, and erosion in agriculture. A properly compacted soil is important in construction, as in infrastructure, to achieve maximum soil strength. In order to do the experiment, materials you need are a ruler, a sieve, a mold to put the soil in, a drop hammer, and a sample of soil, and a balance.
Alright, next then we'll have to sieve out all the large particles in here. So we dump all our dirt into the sieve. Sieve it real nice, get a little dust on here. And then after we sieve out all the large particles, we take our paper and then carefully try to dump it into the mold. Just a pretty wave amount. And I generally like to go halfway. So we'll clean this up, and then we'll take it back to the scale and weigh it. And as you can see, it is 804.02 grams.
Now we have to figure out the volume of soil in the column, and in order to do that, you have to figure out the height of soil in the column. So we have to take the total height of the soil column, which is 36 centimeters, and subtract how far down the soil is. And the soil is 20.5 centimeters down. So that means that 36 minus 20.5 is 15.5. So the height of soil is 15.5 centimeters. And we plug that into the same equation as before and get the cross-sectional area, which is pi r squared. And then times that by the height of soil, which is 15.5, and then you get your volume of soil, which is 684.79 centimeters cubed.
So determining the bulk density of the soil pre-compaction, we just take those two measurements that we had, the dry mass of the soil over the volume of the soil, which was 804.02 grams over 684.79 centimeters cubed, which equals 1.17 grams per centimeter cubed. So now we're going to compact the soil 25 times with the drop hammer from about 12 inches. You guys ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25.
Alright, so after the compaction, we need to determine our volume again. So the cross-sectional area is going to be the same at 44.18 centimeters squared. So really we just need the length. So our length is at 24 centimeters. So we're going to take the soil column length minus the 24 centimeters. That's going to give us a 12 centimeter length. So then we're going to take that times our cross-sectional area. Okay, pause it. So then we times that, we get 530.16 centimeters cubed. To get our bulk density, we're going to take our mass of the soil, which we originally weighed was 804.02 grams divided by 530.16 centimeters cubed. And this will give us about a 1.5 grams per centimeter cube. And as you can see, this bulk density is greater than our original bulk density.
Now that we have calculated compacted dry bulk density, now we're going to do it by adding water. So your first step is to determine how much water you need to add. And you take how many grams of soil that you have, and ours was 804 grams, and you times that by 0.1 grams of water content. And ours came out to be 80.4 milliliters of water. Milliliters are the same as grams. So your first step is to pour your soil into a sieve, because you're going to want to add this to water. Oops. Spilled a little bit. So if there's any like excess big pieces here, you want to get that out of there. So your first step is to add little bits of water. And try to make like a big mud ball, which I compacted. You're going to want to try to get as much as you can saturated. Then once you get it pretty good, then you want to put it back in the cylinder. And once you get most of that in here, then you're on to your next step.
The next step is compacting the soil. So we're going to put the drop hammer in there and drop it 25 times like we did previously. 1, 23, 24, 25.
So after we compacted the wet soil, we then measured its volume and determined the bulk density. And the bulk density of the wet soil after compaction was 1.65 grams per centimeter cube, which is 0.15 higher than our dry compacted soil.
Alright, after you completed both bulk densities, you are now able to have your conclusion. You can also do this experiment, adding water to increase bulk density, to find maximum compressibility by slowly increasing water content and repeating by dropping the drop hammer 25 more times to determine new bulk densities. This process can be repeated till maximum compressibility is achieved and bulk density does not increase, but then stay the same. This is how you do soil compaction, and thanks for stopping by.